here we go. So recording should be started now. Yes, recording is started now. Per what you guys would like, I am now going to start recording homework assignments. This is now, or office hours, sorry. This is homework chapter 2, question number 33. In general, the question for this is find the mass in grams of one atom of the following element. Okay. So A is, I think BI, if I remember correctly, should be bismuth. Bismuth has an atomic weight equal to 208.9804 atomic mass units. Okay, so I believe in this chapter, and this is supposed to be sections 2.1 to 2.3. Let's see, flipping back through the chapter real quickly to make sure that I reference this appropriately. Isotopes and atomic weight. This very likely is in section 2.3. Come on, where is it? No. Okay, where do they actually talk about this? They discuss this in, so we're talking about one atom of bismuth. And okay, there's a number of ways of doing this, but the easiest way to do this is to say that so we know that the atomic mass is 208.9804 AMU. Now my question to you guys first and foremost is this enough information? Well, actually I should ask, does anyone know how to solve this problem? I'll open it up to the room. Does anyone know how to solve this problem? Or is everyone confused? Let's see, chat says, glancing at the chat. Let's see. Okay, so Karen, you say you think you know how to solve it? Please, let me know. So how would you go about doing this? Let's just say that you trust yourself and go for it. How would you go about solving this? Okay, so you know what a mole is, and we haven't covered that in the course yet. So that is fantastic that A, you know what a mole is, and B, you know what the molar mass means. However, technically in this chapter, you don't need that information to come up with the answer. You're absolutely right. You can use that to solve it. However, it's not essential. Sorry, please go ahead. I did not mean to interrupt you.
So we have to figure out the mass in grams, right?
Of one atom, right?
Of one. So wouldn't we use that AMU and multiply it by maybe by the electrons, or I'm guessing something like that, maybe?
You are, I'm relatively certain I can grasp where you're going with this, and you are headed exactly in the direction I was headed in. Correct me if I'm wrong. You are thinking you need the mass of a neutron, the mass of a proton,
Mm-hmm.
and the mass of an electron. Is that where you were going?
Yeah.
Precisely, yes. There's also one other piece of information, therefore, in order to make use of this, that we technically would need if we wanted to get the mass accurate. Well, within the degree of accuracy that we were going to calculate this. And actually, you don't need the mass of the electron necessarily. They are so negligible that they don't make a huge difference. But you know what? I will use it just to show you guys that they are negligible. Okay. So to begin with, the mass of a neutron is 1.674. We're just going to round it off to 675, actually. You could go a little bit further out and utilize a whole set of numbers. I think it goes out to 927, but let's just use 1.675 times 10 to the minus 24. I think that's in grams. Yes, it is. And then we've got the mass of a proton at 1.673 times 10 to the minus 24 grams. And finally, the mass of an electron I usually use is 9.11 times 10 to the minus 27 grams. Okay, so those are the masses of our subatomic particles that we'll need for this. What is the other pieces of information that we need for this situation, though? Because remember, these masses are per one subatomic unit. So right now we only know the mass of one of each of those.
Do you need the charge?
So charge is not going to come to play into this particular question, but it is you're thinking in the right direction. We need to know something else, and that is a component with regard to subatomic particles in general.
We need to know the atomic number.
So we've got the atomic, yes, we've got the atomic mass, and we do need to know the atomic number. Actually, we have the atomic weight. This is the atomic weight.
Okay.
So here we have the atomic weight. What we need is we need atomic number, and we need the appropriate term here would be the mass number.
Oh, okay.
Because there's a slight difference between the mass number and the atomic mass or the atomic weight. The atomic weight or atomic mass are the values in AMU, and the mass number, so our...
The protons plus the neutrons.
Exactly. So mass number is equal to the actual number of protons plus the number of neutrons. The atomic number is, of course, we also know equal to the number of protons.
Mm-hmm.
And the atomic mass units are actually calculating the mass of the nucleus. And if we're taking the one from the periodic table, of course, that's the weighted average of the isotopes. But this is actually very close to the mass number. Usually people, what they do is they just round this off to a whole number to get the mass number. And so therefore, bismuth will have a mass number equal to 209. And the atomic number, of course, we can get from our periodic table. Let's see, I know I just had it open. The atomic number for bismuth is 83. That is not one of the ones I know very commonly because it's not an element I use very often. The only things I associate bismuth with tend to be Pepto-Bismol, the pink digestive aid that people often use. And bismuth is the element that is a part of the bismol, Pepto-Bismol. It's bismuth succinate, I believe. So bismuth is actually something that people take daily throughout the world. Anyways, that being said, let's first determine what? Well, we need to determine the number of our subatomic particles, right?
Right.
Okay, so how many protons do we have?
$83.
Absolutely. So we have 83 protons. Come on, work with me here. There we go. And now, how many electrons? Maybe I'll add as an addition to this that this is a neutral atom. This is not a ion. If you've started reading about ions, this is a neutral atom that we are talking about.
Would it be 0?
Ah, so that's a interesting suggestion. However, it's a neutral atom. There are only two types of charged particles here. You've got protons and electrons. And if you've got 83 protons, how do you end up with a neutral 0 charge?
You have negative. Like, would it be the opposite of it?
So you've got 83 protons. So in the nucleus, you've got a positive 83 charge. Does that make sense?
Mm-hmm.
Okay. So therefore, the atom needs to be surrounded by 83 electrons, giving you a negative 83 charge surrounding that nucleus to give you a neutral total charge of 0.
Oh, so it's positive.
It's a positive value because you can't have a negative number of electrons. That's not possible. That would be like telling someone that I ate negative 5 sandwiches.
Mm-hmm.
And that just doesn't make sense, right? Yeah. So therefore, it has to be a value equal to 0 or larger. And therefore, since the number of protons is 83, giving us an 83 positive charge, we need a presence of 83 electrons that have, therefore, a total charge of negative 83 coming from that quantity of 83 electrons.
Mm-hmm.
Good so far?
Yeah.
Okay. So finally, then we go to the number of neutrons, which comes from taking our mass number 209, subtracting off of that the number of, because we're referring now up to this equation, this guy right here, the mass number is equal to the number of protons plus number of neutrons. So therefore, if we take 209, subtract off it the number of protons, which we've already determined is 83, then 209 minus 83 is what, sorry? 126?
Yeah.
I would agree with that. Yes. 126 neutrons. Exactly. Good so far?
Yep.
Okay. Any questions from anyone? Okay, so if there aren't any questions, then we'll go on to the next slide. And the second step here, therefore, is to calculate mass. Calculate with an E. And then, of course, now that looks like calculate mass as one word. So let's try 2 words. So calculate the mass. So this is now just a summation, essentially. We have 126 neutrons multiplied by the mass of a neutron, which I think we said was, yeah, there it is, 1.675, and that is grams per neutron, plus we have 83 protons. Multiply that by the mass of a proton, which we said was 1.673. Wait, no, this is, of course, times 10 to the minus 24. Can't forget that part. Times 10 to the minus 24 grams per proton. And then finally, we add to that just to make it observable. We can do this real quickly with and without the electrons. So we have 83 electrons multiplied by 9.11 times 10 to the minus 27 grams per electron. Okay, so.
Oh, so I see what we're doing. So for every amount of neutrons for whatever the element is, you have to multiply it by the mass of that neutron.
Exactly.
Yeah, okay, I see what it is now.
So now I'm going to show you very quickly that the electrons do not make a huge difference in the mass. 1.675 times 10 to the negative 24 plus 83 times 1.673 times 10 to the minus 23 plus 83 times 9.11 times 10 to the negative 27. And there I end up with 1.60 times 0.00003. So I'm just going to take it as 1.600 times 10 to the minus 21 grams. So that's with electrons. And now if we calculate it without the electrons, which actually just means I'm going to go back in my calculator and subtract off, well, actually just delete that value from what I just calculated since my calculator has the display. Go back there, and we get 1 point, it actually does round back up to that, because so this is actually from 1.600396 13, I think it is, times 10 to the minus 21. And here without is 1.59964 times 10 to the minus 21. So you can see how close those values are. They're so close.
Right.
That were you to take it to 3 sig figs, it would, or even 4 significant figures, it does not make a difference to count the electrons. And so therefore, we just generally don't bother calculating with the electrons, which is nice because that's one fewer steps you got to do. So, does that make sense to you guys?
Yes, perfect.
Excellent.
I will let her know this is how you do it. Thank you so much, Professor. I really appreciate it.
You are very welcome.
All right. Thank you. See you tomorrow.
Not a problem. Have a good day, good night, etc.
Bye-bye.
Bye. All right, what other questions do you guys have?
I have a question on the oldest assignment, but if somebody wants to talk about something current, they can. But mine is just, I so do not understand the log thing on the math assignment.
Okay, so from the first lab assignment,
Yeah, the dry,
logarithm.
yeah.
Okay.
I have no idea how you would even um figure it out manually or whatever it said, like,
Oh, no. You would not. You would
okay,
not. You would not do that manually. There are ways of doing it manually.
approximate without calculator. How would I approximate that without calculator?
So if you look at that assignment, see if I
Mhm.
can find it. Where did I put it? On my computer. There it is. If you're looking at that first page, it says, once you've complete, okay, so please carry out the math on your, well, I hate the wording of that, on your head without your calculator. Yeah, that's just bad writing. So it should say, yeah, so leave the space blank if you cannot perform the calculation. So you're not expected to be able to do all of these.
Okay. Oh my gosh.
Yeah.
I was like
Yeah.
freaking out for,
Yeah.
and I was like stuck on that forever. And then, I mean, there's so many things that has gone on this week. So I was like, okay, so since I didn't have to do that by myself, then I don't have a question on that.
Okay.
I'm sure I'll have other questions, but I will get them already. I forgot about what time the office hours was, so I'll come to the next one more prepared, but I want to
Okay.
get as much information as I could. So
No problem. I hope the calendar helps with that, but
Yes. I just forgot. I'm still technically working from home
okay.
at the same time, but I'm not getting any calls, so I'm able to listen at the same time.
No problem. I got you. I mean, heck, I went to the chemistry department meeting while at work, technically by sliding my Zoom avatar, whatever you want to call it, into the meeting, and then just having my headphones on and putting, silent and no camera and tucking it in my pocket. I listened to the whole thing and just let people know on my break that that's what I was going to be doing because I wanted to be there for the meeting, but obviously I had to work.
Yeah. Same here. All right. Thank you.
You bet. Thank you very much. All right, guys, what other questions you got? We definitely still have time left.
Hello?
Yes.
Hey, so I have a question about the materials needed. I've been lost trying to find what I need. I found a lab manual, and I know I think there's two other books or something, and one of them is the homework for lab, and the other one's for lecture, I think.
Okay, so when it comes to this course, the required materials as far as texts go, there's only one textbook that you need, and the lab manual may be available in the bookstore. They still haven't told me. I don't even know if the bookstore is open yet. But the lab manual, they've given me a digital copy of it, and I have taken it and split it up into small PDF chapters essentially, and posted those on the Canvas site for your specific lab.
Okay.
So the lab manual should not be something you need to purchase. The lab manual itself is something that you can either download and print out ahead of time, and I'm gonna tonight post and send out a copy of whatever chapter you guys or assignment you guys need for the lab as well. Please do make sure. Are you on Tuesday or Thursday?
Tuesday.
Okay, so please make sure you have goggles for lab. Did you make it to last week's lab?
No, I sent you an email about it.
Okay.
Unfortunately, I wasn't able to. But
Okay, no problem.
this coming one, I'm coming.
Okay, good. Essentially, please do make sure you have goggles, and make sure that you also wear closed-toed shoes, which means shoes that totally cover your toes and your entire foot, not just your toes.
Yeah.
Which also means no Crocs, no shoes with holes in them, because I know that some people have told me Crocs cover their feet, but they don't because they have holes. And ideally, clothing as far as like either a dress or pants or whatever garment you wear from the torso down, covering your legs, and of course something covering your your torso and above. Your arms are free to be not covered if you wish, but you need to cover your legs, you need to cover your upper body as well, and you need to have goggles and shoes that entirely cover your feet.
For the goggles, is this supposed to be like a secure lining, be like between the eyes and the face?
Ideally, yes. In the very least, they cannot be safety glasses. They must be safety goggles. They must have you know what goggles are, right? You know, you think of
Yeah,
swim goggles, right? They completely should seal around your face. Uh, if the seal is not perfectly sealed, that is okay for this course. It's not ideal. Ideally, you'd want one that would seal perfectly the way you would for swimming goggles. But if they are the type that generally seal but have a little bit of leakage, for this class, you'll generally be okay because we tend not to use anything that is terribly terrifying. However, strong acids, strong bases are a part of this lab. And if you happen to get some of that material and it flies up into your face, yes, you might get a little bit of a facial scar, but if it hits your eye, obviously that's going to
yeah.
do a lot worse damage. In my insert number of years here, which is greater than 5, we'll say, years teaching chemistry labs, I have never had anyone get hurt outside of, you know, a small burn from not paying attention to whether or not they were using a hot plate or Bunsen burner and needed to let it cool off. That being said, I still absolutely make sure that everyone takes every precaution because you never know. Accidents happen.
Yeah, okay.
Yeah.
Another question. I look into the modules on the lecture for Canvas, and it
Yes.
says from the back of chapter 2, it says the numbers for homework. Is that the same book for the lab manual, or is that like a completely different book?
So have you been able to find the syllabus?
I found it, but it just doesn't let me download it.
Oh, that is strange. Well, I'll have to review the Canvas and make sure that it is accessible. The syllabus should point out, and hopefully I sent this out in an email, but I'll send another reminder. The text you need, let's see here. I'm going to close this temporarily and let's actually open up the syllabus. Let's see how I can do this. Work with me, computer. So the syllabus, and it is this one right here. Okay. So view presentation. There we go. That's better. So now if I go here and share this with everyone. Okay, so if you can see my screen now,
Yeah.
the required text on the syllabus is right here under required text. It is Fundamentals of General Organic and Biological Chemistry, 8th edition by J. McMurray, D.S. Ballantyne et al. I believe it's a Pearson text from 2018. It's the only physical text that you guys are required to obtain in however managed you require it. When I say physical text, that doesn't mean you actually have to get a physical book if you don't want to. If you can obtain in whatever fashion you can an ebook of it, that will work as well. But it does need to be this specific book, The Fundamentals of General Organic Biological Chemistry, 8th edition by J. McMurray, D.S. Ballantyne et al.
Do you know if the library sells those books?
The library, I do not know if they have a copy of it. The library, I don't think even opens until February 22nd, unfortunately.
Oh, damn. All right.
Yes. Yeah. So I'm sorry, there's nothing I can do about that one.
Yeah.
What you can do is if you have any classmates in the course, you of course are welcome to ask them to, you know, text you photos from the backs of the chapter, or you know, if they happen to have a way to help you get a copy of the book. I'm not going to say that you're pirating the book because of course you wouldn't do that. But if you happen to have them provide you a link from which you might be able to obtain the book, of course, purchasing it, then you would do so. And do you happen to have any friends in the class? I hope, but you know, obviously you have friends, not necessarily in the
Yeah.
class.
No, I'm probably just gonna buy it online.
Okay.
I was just wondering, do we need it in class or?
Okay, so the lecture is purely asynchronous, meaning they are whatever YouTube videos I post of other people combined with videos I record of myself for the lecture.
Yeah.
As far as the lab is concerned, you do not need to bring the physical text to the lab. It will not be useful to you in the lab other than to give you something to I guess, give you a further workout walking across campus. It'll stay in
Okay.
your backpack.
Okay, okay. Thank you. I appreciate it.
No problem. You're most welcome.
All right, have a great day.
You as well. Have a good day. Let's see. Is there anyone still in the office hour room? Oh, it's just me here. And what time is it? It is almost time to end office hours. Okay, we'll give it another minute or two. And we will pause